Okay, we're on page 15. And on page 15 and 16, we're going to look at some random examples that are a little bit different, a little bit harder. Okay, so we've got a bag with 6 white and 4 blue. So W for white, B for blue. 3 marbles are drawn. And at each draw, if the marble is white, it's replaced for that draw. And if it's blue, it's not replaced. So what's interesting about this question is we've got a combination of replacing or not replacing dependent on what we pick. So definitely my first inclination is to use a tree diagram to kind of draw out the options and think about the probabilities. Okay, so let's draw it out. So you can either get white or blue each time. So nice big diagram, start from like the middle there, white, blue. That's my first draw. My second draw can be white or blue. White or blue. And my third draw can be white or blue. So that's my first, that's my second, that's my third. I'm going to write my outcomes here. So going across white, 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 blue, white, then going down to blue, then white, white, blue, 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 white, white, blue, white, blue, 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 white, and blue, blue, blue. So that's all my options. And you'll see there's 8 options there, outcomes there. Okay, they're not all equally likely. We need to put the probabilities on them. So for the first ball, now there are 6 white, 4 blue. So it's going to be 6 out of 6 plus 4 is 10. 6 out of 10 are white, meaning 4 out of 10 are blue. Now, if we select a white, whenever we select a white, we replace. So for this first one where I've selected a white, I'm replacing the white, so the odds will be the same. So 6 out of 10 and 4 out of 10. Likewise, if my second is a white, the odds will still be the same. I'll replace that white. It'll still be 6 out of 10 and 4 out of 10 there. Okay, but whenever I select a blue, I'm not replacing. So here, 4 out of the 10 were blue. I've selected a blue and I've thrown it away. So now I've got 3 blues left and I've only got 9 to pick from. So that'll be 3 out of 9 blues. So logically, to make that add to 1, that must be 6 out of 9 whites. Okay, following this path here, I've selected a blue and I'm not replacing blue. So I had 4 out of 10 blues here. I've picked a blue and I'm not replacing it. Chuck that blue away. We've got 3 blues left out of 9. So that'll be, to make this one whole, this will have to be 6 out of 9 there. Let's keep going down the bottom. So I've selected another blue. So I had 3 out of 9 blues. 3 were blue out of the 9. But remember, for blue, we're not replacing. So I've selected a blue. I chuck it away. Now I've got 2 blues left, and I'll only have 8 marbles left. So that means that must be 6 out of 8. Okay, so here, this second ball was a white. If the second ball is a white, remember we replace, which means that the probabilities for the next one will stay the same. So if there was a 6 out of 9 chance of getting white, that'll stay 6 out of 9. And this will then therefore have to be 3 out of 9 to make it a whole. So there's my tree diagram. So we should be able to work out the questions now. So the first one says no blues. So no blues infers that they've all got to be white. White, white, white. So following the tree diagram, it's going to be 6 out of 10 times 6 out of 10 times 6 out of 10. It's just that option there. Okay. By the way, when you do this in your calculator, you just use one fraction bar and just put all the numbers like that. Okay, or you can just do 6 out of 10 cubed for that particular one. So I got 27 out of 125. B, 1 blue. Okay, so let's have a look. Which options have 1 blue? That's 1 blue, that's 1 blue, and that's 1 blue. Have a look through. Yeah, there should be 3 outcomes. If there's 1 blue, the blue ball could be the third ball, the blue ball could be the second ball, or the blue ball could be the first ball. Okay, so we need to now work these out one at a time, and be careful because there are blue balls involved here. The properties will change, so we've got to be careful with the way that we do it. So I would follow the branches and multiply for each one. So white, white, blue, 6 out of 10, 6 out of 10, 4 out of 10. Next one, white, blue, white. White, white, blue, white. So just times them. So 6 out of 10 times 4 out of 10 times 3 out of... Oh, hold on. The last white is 6 out of 9. Notice that because I've selected a blue there, it's reduced the total for the next one. So instead of out of 10, it's out of 9. And then blue, white, white. So 4 out of 10 times 6 out of 9 times 6 out of 9. It doesn't drop the second time because the white one that you pick second you replace. Okay, so into your calculator, I got 632 over 1125. C, two blue marbles. So let's have a look. We want 2 blues, so let's go through which outcomes work. I'm going to put a C next to them. 2 blues there, 2 blues there, and 2 blues there. So 3 options. Because if there's 2 blues, there must be 1 white. So the white could be the first wall, the white could be the second, or the white could be the third. So blue, blue, white. Okay, so let's have a look. So let's do one thing at a time. So white, blue, blue is first. So white, blue, blue. So 6 out of 10, 4 out of 10, 3 out of 9. Notice when you pick the blue, we're not replacing. So the amount of blues goes down by 1 and the total goes down by 1 when we select a blue. Next one, blue, white, blue. So follow the path, blue, white, blue. So 4 out of 10. Then white is 6 out of 9. Then the last blue will be 3 out of 9. And the last one, blue, then blue, white. So blue, 4 out of 10. 1 less blue, 1 less total, so 3 out of 9. And 1 less out of the total because I've selected another blue. This will be 6 out of 8. Into your calculator, and I got 121 over 450. Okay, for part D says 3 blues, so probability of blue, blue, blue. Okay, you can just have a look. B, 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 that's the last option there. Only one way of doing it. All of them have to be blue. And because we're not replacing when we select the blue, we can see it goes down by 1 each time, and the total goes down by 1 each time, and we get 1 out of 30. Okay. So that was that one. That was an interesting one, where we had replacement mixed with not replacing. So that was an interesting one. This one's another interesting one on page 16 here. We've got a game that 2 people are playing, and they take turns. So Sam wins. So Sam wins if there's a 1 or a 6 on his turn, and Cleo wins if she throws an odd on her turn. So odd being 1, 3, 5. If neither person wins on their throw, the play reverts to the other person until one person wins, and Sam goes first. So this is what happens. So Sam goes first. The only person who can win on the first throw is Sam, and he wins if he throws a 1 or a 6. So 1 or a 6, that's a 2 out of 6 or 1/3 chance. So there's a 1/3 chance that Sam wins. Okay, or if Sam doesn't win, I'll put Sam and then not win like that. That's a 2/3 chance. So once Sam goes, then it's Cleo's turn to throw. So notice if Sam wins, the game's stopped. We don't go further with branches like this. So we can't go further with branches like that. If Sam wins, that's the end. But if Sam doesn't win, we've got 2 options. So Cleo's tossing, and Cleo can win or Cleo can not win. And then if Cleo doesn't win, the game keeps going. So what's Cleo's odds of winning when she tosses? Well, she's got odds, which is 1/2 of winning. one half not winning. Okay, so if Cleo wins, game stops. If Cleo doesn't win, the game keeps going, and it goes back to Sam's turn. So Sam winning will then be a third, Sam not winning 2/3, and then we repeat the pattern, right? Cleo winning, Cleo's turn to throw, half chance that Cleo wins on that turn, half that it doesn't, and then keep going and so forth. And hopefully you can see that this tree diagram will actually go on forever, because there's always the chance that you're not going to win on your throw, in which case the play keeps going. But I'm going to stop it there. So what's the probability that Sam wins on his first throw? So Sam wins on the first. So probability that S wins on first. Well, there's a 1 out of 3 chance for that. That's easily established. B, what's the probability that Sam wins on his second throw? So probably that Sam wins on second throw. So for Sam to win on the second throw, we need to be here. So that's because that's Sam's second throw. So you need to follow the path to get there and multiply as we go. So that'll be 2/3 times 1/2 times, and then Sam winning is 1/3 there. And the 2's would cancel nicely, and that's 1 out of 9. So there's a 1 out of 9 chance that Sam will win on the second. And part C is, what is the probability that Sam wins eventually? So Sam could win, if it's eventually, he could win on first, he could win on second, he could win on third. And it says leave your answer as an infinite sum. So you can see that this is going to keep going on forever and ever. So I'll do part C up here. So probability Sam wins eventually is going to be probability that Sam wins on first plus probability that Sam wins on second plus probability that Sam wins on third, etc. I'll put plus dot I'll put. So we already know that the probability that Sam wins on first is a third. Part B, we worked out that he wins on the second is a 9th. Let's work out the probability that he wins on his third go. So let's see if we can see. So he's got a not win on his first. Cleo's got a not win on her first. He's got a not win on his second. Cleo's got a not win on her second. And then he's going to win on his third. So that's going to be times a third. And hopefully you can see that a lot of 2's cancel out here. We've got a third times a third times a third. And I think we can start to see a pattern, right? A third times a third times a third is 1 over 27. I think you can guess what the next one's going to be. You're going to times by another third. It's going to be, if you times 27 by 3, you get 81. And then it's going to keep going, okay? So that's how you would answer. As an infinite sum, you would add and you'd just put dot 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 at the end there. 3 terms and then plus dot 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 is enough to show the infinite sum. So I like that one because that was a game that just kept going. So that was a nice question, a bit different. Alright, see you in the next video.